next speaker is Heidi Seibold. Heidi is a statistician at the LMU Munich, where she works in statistical methods for personalized medicine. She has a PhD from the Epidemiology, Biostudies and Prevention Institute at the University of Zurich, and she is a core member of OpenML and the LMU Open Science Center. In her talk, Heidi will address reproducibility statistics and in machine learning.
Okay, well, thank you. This is very long. Okay. First of all, thanks so much for organizing the summer school. It's been an amazing experience. I've learned so much. When I first saw the first tweet about the summer school on Twitter, I was like, oh, I'd love to go to this. This sounds amazing. And then a couple of days later, they asked me to be a speaker, and I was like, yeah, I'm going to come, and I'm going to stay all the days. So I'm very excited to be here and feel very honored to be among the speakers. The slides are available on this link. I also put it in the HackMD. Please feel free to ask any questions during the talk at all times. If you're shy, you can also ask questions on the HackMD, and I'm going to try to answer them as well. Yeah, you basically said most of the things about me already. I'm working at the LMU in Munich now, and I'm part of this data integration center. It's like a big medical informatics project. Very exciting new stuff at the hospital. I'm also assistant editor for the Journal of Statistical Software, where I do reproducibility checks. So in the Journal of Statistical Software, you always have to have an example how the software works. And I'm responsible for making sure that this also runs at least at time of the publication. You'd be surprised how hard this is. So how hard it actually is to get this ready. Yeah, I'm now a member of the LMU Open Science Center. It's a new center that was started this year that tries to get the university more interested in the topic and also aims at teaching people in this area. I'm going to talk a little bit about OpenML later if we have enough time. I'm going to talk about the tools that I use in my daily work today. Since I'm a statistician and you might not be a statistician, not all the tools may apply for you. But to me, it was very helpful to see how other people do their daily work. And maybe it's also helpful for you, I hope. Open science and reproducible science. I was like, always in the beginning, I was like, why do people always connect these two topics? How does this make sense? And so I felt like open science is like this beautiful world of altruistic scientists or of people wanting to make their research available to others so that science could move forward faster and better. And reproducible science is more like it needs very organized scientists who really focus on this fact that you want to be able to reproduce everything, so to automate stuff a lot. So they're two different things in a way, but at the same time, I feel like I am only comfortable working open if I'm also pretty sure that my work is reproducible. Because otherwise I'm gonna feel very exposed, right? So if I put all the stuff out there and make it easy for people to redo the things that I did, and then they're gonna figure out really quickly that I've done a terrible job, then I'd feel very vulnerable. So I only feel comfortable to making my work open if I think I've done a good job at making it reproducibly. So I just started my postdoc in April, and one of the projects that I'm working on now is this one. So we're trying to predict personalized treatment effects in MS patients. So we want to try to figure out which types of patients respond well to which types of treatments. Because right now the situation is a little bit that it's not really clear, and then doctors try different things and see what works well, which is obviously terrible for both the costs and of course also for the patients, because you don't want to be a guinea pig, right? And this is quite a complex project because we're using retrospective data, so it's not a clinical trial where people were randomly assigned to a treatment, and so causality is always a little bit difficult to know if it's causal is a little bit difficult. And I've tried to figure out how I'm gonna do this project, and so this is essentially the different steps that I'm gonna have in the project, and then the tools that I want to use for it. And so the 4 different steps are data preparation, analysis preparation, analysis, and presentation. And I have analysis preparation and analysis separately because I think it's important to first think about what you want to do and then actually do it. So first, now I'm in the step of data preparation. I go to the hospital, and I've set up like the computer a little bit, or at least the IT person has set it up for me because I'm not allowed to do it myself there. And so I've R installed, I've Git installed. I have no access to GitLab yet, so I'm still trying to figure out how I can get out of the firewall of the hospital to be able to really version control my code. But this is definitely something I want to have, because right now I'm essentially, at the end of the day, I'm copy pasting my code onto GitLab in order to have it backed up in the way that I'm used to, which is obviously not very, very good. One thing that I also use for all the steps is Make. So Make is a way for me to automate the whole process, and I'm going to talk a little bit more about it after. And also, I'm the kind of person who has, how did Tim say it, the kitchen sink approach. So I have every project in one virtual machine, and I set up this virtual machine at the start of the project, and then I install all the things that I need. And then when the project ends, then I turn it off. Is that how you say it in virtual machines? I don't know, really. I'm not a computer scientist. But that's essentially what we do. And if I need it again, I can use it again. But it's always staying in the same way it was before, in order for me to be able to, if the reviewers' comments come in, then I don't need to worry about having a new R version or something. And then, so in the data preparation step, it's very important for me to talk a lot to the doctors, because there's a lot of questions that I have about the data. So for example, we're analyzing MRI images, and we want to know, so our outcome is are there any new lesions between month 6 and month 24 after start of the treatment? So obviously not all the patients came in exactly at 6 months after treatment start. So we have to figure out which range we allow for that. And this is something where I need to discuss a lot with the doctors in that sense. And so what I use for that is R Markdown. So I create the script. So if you're a Python person, so it's also like a notebook. R Markdown is like a notebook. And I can convert it into Word, and they're used to working with that. And then they can just comment in there and understand what I'm doing. So I always create a version with the code and without the code, so they can once just read the text and look at the figures, but they can also try to understand what I'm actually doing. So this is very nice for collaborating with the doctors. In the analysis preparation step, I want to try to figure out which methods I actually want to use in the analyses. And I think it's very important to decide this in advance, because otherwise I'm going to try different things, and then I'm going to pick the one that works the best. And that's not a good idea. So you always want to figure out which statistical methods you want to use in advance. And in an optimal case, you also want to pre-register what you want to do. So my plan is to write an analysis plan and put it on the Open Science, is it Open Science Framework, OSF? Yeah, Open Science Framework. For others to be able to later see, oh, did she actually do what she said she was gonna do? Which might not be the case, but at least I'm trying, right? we don't know it yet. And then I'm doing the analysis, and in the end I will probably present the results in a paper, give some talks. For paper writing, I use knitr. It's like the combination of R and LaTeX, which is very common, I would say, in the field of statistics. And then I'll put a preprint up before I submit it to a journal, which I usually do to make. I do publish also in closed access journals, but I always have every paper also available as a preprint, and in this way I make sure that all of my articles are accessible for everyone. Yeah, so this is like the idea that I have for this project. I use other tools as well, so I've tried to map it out. So we learned yesterday about mind maps. This was my mind map for tools that I use. And I think I've created some bigger categories. They're not optimal, but they're like good enough for now. So I will start with like organization. So not all of these are really software tools. So for example, you see folder structure is not a software, but I think it's very important to work reproducibly. If you have like a smart folder structure and you know where to find everything, then your work is going to be, it's going to be much easier to work reproducibly. And then I use GitLab issues for organizing my life. So I have one repository which is closed, and where I have just like, tomorrow I need to do that. And until the end of August, I need to have done that. So this helps me to stay on top of things somehow. Then, yeah, version control. I obviously use Git, but I also use SVN for writing R packages. I think when I work with people who do not know Git or SVN, but they know LaTeX, then I like online text editing, so I use Overleaf because it has integrated version control, so I feel safe and they don't feel overwhelmed, which is nice. And then I have this under version control, but using virtual machines or Docker is like, yeah, it's like it controls the environment, it controls that I have a stable version of R and it doesn't change in that sense. I have tried Docker, by the way, and there I hit a technical limit. And so I've tried it for one project, and I had like a weird error with like some kernel issue, and I'm not a computer scientist, so I couldn't figure it out, and I was like, I'm going back to virtual machines. But I think that connects a little bit to like, it's important that we make tools as easy as possible to use. And I would consider myself someone who likes trying new stuff, but if it takes me too much time, I mean, I have to give it up at some point. Yeah, for automation, so I work on Linux, so I obviously use the terminal a lot, and I think it helps me being more productive and faster in doing stuff. So I can recommend using Linux. First I had both Linux and Windows on my computer because I was so scared that it won't work for me. But then over time I didn't use the Windows anymore, and I was like, why do I even have this? And so now I have only license-free software on my computer, which I feel really good about. Yeah, then I use Make for automating stuff. I use R. You probably already know that. And I use Knitr and R Markdown, which I also count, I put it up for both automation and documentation because I feel it's very much in both parts. Yeah, you agree. Yeah, so documentation is, it's essentially using words to describe other things, right? And so LaTeX and Knitr, R Markdown are obviously ways to write down words. Roxygen is a way to document R functions, which is super cool. So you have the R function, and above the function you have the information on what the function does and what all the arguments do, which is super helpful even if you're not writing an R package. I use it for all the functions that I write because if you later go back, you're not going to understand the function anymore, and you're going to have to read the code, and it's very tedious. And if you can just look at the documentation you wrote, it's going to be much easier for you. And then also put naming there. It's like folder structure. It's not really a tool, but it's really, if you use it right, it can be really, really helpful, I think. Yeah, then on the publishing side, I have GitLab, where I publish my code, obviously, but I also publish my slides on GitLab. Then I have a couple of online presences. I don't know, they don't really do anything about reproducibility, but they're just good, I think, for promoting myself as a researcher. And I just wanted to put it there because I think it's like part of open science. It's really cool, but if people don't know about you or your work, then it's not so helpful. So I have a Twitter account, for example, and I feel like this has helped me a lot in telling people who I am in my field. So I think that's pretty cool. And I feel like these things matter more and more as a researcher. Then on the Open Science Framework, you can publish all kinds of stuff. So you can essentially publish everything that you have in your research project. OpenML is a project that I'm involved in where you can publish code. Publish data, but also the questions that are linked to the data, so the machine learning questions. So you could have a regression task or a classification task that's linked to the data in a machine-readable way. And then you can download this question in the data, and you can ask a question, run an algorithm to solve the question, and then upload it again, and it's going to be linked to the question, and you're going to be able to see how well did your algorithm do compared to other algorithms that were run to solve this task. And then I think preprints are very important, and obviously journal articles are our currency as scientists. So yeah, I guess these are like the tools that I use for my research in general. And many of them play into reproducibility as well. So are there any questions so far? Okay, then I'll go a little bit deeper into some of the things. I think Make is a really cool tool. It's pretty hard. Sometimes I don't, once I've set it up, the Make file, then I'm pretty happy with it, and I can automate the whole process from the beginning, where I think about the analyses through the data cleaning and the analysis to, in the end, having the PDF of the paper. And so I can automate this whole process with Make, and this is pretty cool. So what you essentially do, you have a target. So for example, I want to create the PDF of the manuscript. Then I have a couple of dependencies. So I'm using LaTeX. So I have this text file where I write the text, and then I have the references in the bib file. So these are the two dependencies that I need to create the manuscript. And then I have below in red, I have the command that creates the target from the dependencies. And so now if I change one of the dependencies and I run make, then it'll understand that one of the dependencies was changed, and it needs to rerun the command. If I didn't change anything, then it's going to tell me there weren't any changes, so I don't have to run anything. So there's two ways of doing that. So I could create the manuscript using the command make manuscript PDF, and then it will only do that. Or I could have also a command that says what are all the outputs that I want to generate, and they can make all, and then it's going to generate, I don't know, it's going to run the analysis code, and then it's going to run the data pre-processing and all the stuff, and in the end give me the manuscript as well. Okay. I already talked a little bit about online text editing, so I think this is super helpful, because not everyone that you work with is gonna be able to use Git or is gonna be willing to use Git. And I think online text editing is quite an easy way to get around it if you feel comfortable doing it online. So I've written a paper before on Overleaf, and it was very convenient, and you can have different versions, and I didn't need to explain how Git works to my collaborators, which is sometimes something that you'd want. And also, when someone doesn't really know LaTeX yet, it's quite easy to use this. They don't have to install anything. So it's easy to get them up to speed. I think Google Docs has also version history, so we use that sometimes as well for like, I don't know, if we have a call and we just write down what happened in the call. We sometimes do that in Google Docs. I think Microsoft OneDrive, which allows you to have Word documents online, also has some sort of version control, but I don't know it that well. So I've only used it once because I had to work on a Word file, which I usually try to avoid. Yeah. And then I also mentioned folder structure before, and I think this is really, really important, because this is something that I messed up in the beginning so many times. And I started off with the project, and I thought, oh, it's going to be a simple project. I'm going to have it all in the same folder. It's going to go very quick. And then suddenly you have this mass of of files in there, and you don't know what's what anymore, and you don't know what's useful or what's not useful anymore, which you should delete or cut. I don't know. So now I have this folder structure that is essentially the same in every project. So I have the stuff that I need for the manuscript in the main folder. Then I have a folder that's called Journal Correspondence, where I have the review stuff, so the informations I get from the reviewers, my responses that I write. And then I have one folder that's called Analysis, where I have obviously the analysis in there. And a subfolder from that is going to be data, and as well one is going to be data original or data raw. Because I always have like a read-only folder for the data that I don't change anymore. And in this way, I make sure that I really have the raw data available. And then I have a code that generates the clean data from the raw data, which is then stored in the data folder or data clean folder or something like this. And I have also a folder that's called basis or something, where I have all the R functions that I use in the project, which I store separately to not have too much clutter in my R code. Yeah, I talked a little bit about online presence also before. So I have a university website, I have a Twitter account, and I have a blog, which I haven't written very much in the last year. And then I also have an ORCID ID, for example. So I have many ways how you can find me online, and I feel like that's super helpful for me. There's a question?
Yeah, I was wondering, do you consider LinkedIn an important online presence?
I don't know. I don't use LinkedIn that much. I don't really understand it that well. But I think if you want to find a job outside of your network, it might be super helpful. Which, to be honest, hasn't been the case for me. So I've always somehow known the people involved in the project that I was applying for. I guess it would be more important if I'd want to leave academia, or if I try to find a job somewhere outside of my bubble. Yeah, and then I use preprints. I have all my papers are also available as preprints. Most of them on arXiv, because that's where people in my field usually publish their preprints. And I have an account on, a page on Impact Story. I can only recommend Impact Story. It's really cool. There you can essentially you can use the ORCID ID and go to people's pages and find the full text or the free available version of papers that people published. So this paper is in a non-open access journal, but it still links to the preprint on arXiv, so you can always find all my preprints online. And you get badges as well, so I have an Open Hero badge because all my papers are open access, which feels very nice. It's made by the same people who have the open access button. Is it called open access button? Yeah. So they do cool stuff, so it's really cool. Yeah.
Is it automatically generated, or do you have to make sure?
I enter it there, yeah.
Okay.
You have to enter it. Maybe for some things they're able to do it automatically, but in this case I said, okay, I have an open version for this.
Yeah. Okay.
Yeah. And then, OpenML is a really cool open source project that I'm involved in. And we have, it's an online platform for machine learning. And there's essentially 4 main elements that we have on OpenML. So it's data, which is a data set. We have, at the moment, tabular data sets. Then there's a task, which is the question that you can ask about a data set. So for example, I want to predict the delay of buses in Zurich. And then a flow is the algorithm, and the run is the application of the algorithm on a task. And you can go to the website and you can actually browse through different tasks and see which machine learning algorithms worked really well on a given problem. And it's really cool for learning, but it's also really cool if you're working in machine learning and you want to benchmark your new method. Then OpenML is definitely super helpful. And yeah, finally, we have open positions in our group. So it's a very new project. It's in Germany, there's this medical informatics initiative where we build up informatics infrastructure at different hospitals. And the idea is to get the data from the clinics into a big data lake and make it usable or more usable than it is now. And parts of it is also research, so I'm like more on the research side. I work on the use cases and show that this data can actually be used for research. And we have quite some open positions in computer science, so if you're done with your PhD and you're looking for a job, we're looking for people. And there's also possibilities to be more on the coordination side, more on the ethics side. So if you know anyone who's interested in that. Also lawyers would be super cool to have. Because it's sometimes really hard to know how to interpret laws. And we don't want to do anything wrong with the patient data because it's very important that it's safe. And I think it's very important that we think about this stuff before we do it. But sometimes we can think about it as long as we want, but we just don't understand the law enough, right? So yeah, these are problems we're having. So if you can contact me if you're interested. There's also this email address that you can email to. Yeah, so that's I guess it from my side. Thanks again for having me, and I'm very happy to answer any questions you might have. And